So this video is on E1 elimination reactions, and I find it a little strange that Professor Pelkey's handout chooses to illustrate E1 elimination reactions with this particular substrate, which is to say tert-butyl chloride in the presence of water, because we've already shown you that one plausible outcome for this particular reaction would be to simply make the alcohol, because we know that the chloride is going to leave, the water will attack, and then eventually something can deprotonate, and you could make tert-butyl alcohol under these conditions. On the other hand, he's right that there are other possibilities that can take place here, and generally speaking, when we're dealing with substitution versus elimination, you're always going to be sensitive to the fact that you can make the substitution products for almost all the reactions we're going to talk about, but elimination is always in the background competing. However, there are things that we can do that would cause the E1 elimination reaction to become much more likely, and they include doing things like heating this up, which is to say adding heat to the reaction, boiling the reaction, or possibly adding sulfuric acid, some non-nucleophilic acid to the reaction. That also would tend to lead toward an elimination product. And we'll talk about this a little bit more in a future video, but basically what's going to happen here is the chloride must leave first, regardless of whether this becomes a substitution or an elimination reaction. Then, of course, we have the cation formed. This should be an equilibrium step because the chloride will be floating around nearby. And so obviously the chloride could simply return, in which case you go back to where you came from. On the other hand, there's another possibility as well, and that is that we have water floating around nearby, and water could come in and add. And so you might imagine, of course, that the water comes in and adds. Then we have a protonated alcohol species. Again, this will be an equilibrium step because the water can come in and the water can leave. But what you have for the moment is a protonated species, which then water could again come in and deprotonate. So another molecule of water could come by and take away this hydrogen. So if you're trying to figure out how the substitution reaction goes, it's relatively straightforward. Chloride leaves. If the chloride goes back, then you go back the way you came. Otherwise, water can come in and attack. That leads to the protonated alcohol species. The protonated alcohol species can be deprotonated by another water molecule, and there you have it. This is the product of a substitution reaction. On the other hand, these aren't the only two things that could happen in this reaction. The other possibility is that water, being a relatively bad nucleophile, might instead find its way into bumping into that particular hydrogen, which could then cause the pair of electrons to kick down and make a double bond. In other words, the other product that is likely to be formed in this particular system is the double bond product. So there are essentially three paths that the reaction can take once you reach this cation stage. Chloride tends to send you back to where you came from, but if you have relatively small amounts of chloride, then it's more likely that water will perform the reaction, be it a SN1 type reaction, or alternatively, if the water serves as a base instead of as a nucleophile, then you get the elimination reaction instead. Big picture, this is an E1 elimination type reaction. It's called an E1 elimination because it is a first order reaction. In other words, the substrate must decompose before anything else can happen. Once again, the leaving group must leave before you form the cation, before then competing substitution and elimination reactions can take place. I have indicated here that I consider this to be sort of the reaction of last resort. When we're talking about substitution versus elimination reactions, the E1 elimination reaction is almost always going to be the slowest reaction of the bunch, and that's because it essentially can only happen when you have the capacity for an SN1 reaction, which is relatively slow, and then you have a relatively bad nucleophile so that no substitution take place. The only way that E1 wins out is if SN1 is slow, and or SN2 and E2 are not possible. So if you have a reasonable base, you never perform an E1 elimination, it instead goes E2. And if you have a decent nucleophile, you don't perform an E1 elimination, you instead make the SN1. So essentially, eliminations only happen, E1 eliminations only happen when the SN1 is slowed down because of the addition of some acid, which tends to make this a worse nucleophile, or heat, which tends to bias us towards the elimination product.